Hello everyone, welcome to our presentation on ClipSitu, a groundbreaking approach in situation recognition developed by our team at A-Star Singapore. We'll explore how we effectively leverage Clip for conditional predictions in this field. Our journey begins with understanding the problem at hand, situation recognition. For this task, given an image such as the one on the right, we first need to predict the verb, which describes the action. So for example, in this image of a fireman, the verb is spraying. Given the verb, we have specific roles that we then predict the values for. So for the verb spraying, the roles would be agent, source, substance, destination, and place. So as you can see in this image, the agent is the fireman, the source is the hose, where it's spraying from, the substance is water, what it's spraying, the destination is fire, where it's spraying to, and the place is outside, which is the location of the action. Lastly, we will also predict the grounding for each noun described by the bounding boxes, or for each of the value of each role. So generally, situation recognition involves creating a structured image summary, identifying the primary activity and its relevant roles. Despite its apparent simplicity, this task presents significant challenges due to the variability in how activities are depicted. So in these images below, you can get an idea of some of the different actions or verbs that are in the dataset, such as hitting, which comes with the roles agent, tool, victim, victim part, and place, or jumping, which is agent, source, destination, obstacle, and place. So semantic role labeling is a process in natural language processing that involves identifying the basic who did what to whom structure of a sentence. In the context of situation recognition in images, it extends to understanding the roles and actions depicted in a visual scene. The primary challenge in semantic role labeling for situation recognition lies in the variability and context-dependent roles associated with a verb. The same verb can imply different actions and roles depending on the context, making it difficult for models to accurately interpret and label these roles in images. So in this data set, we have 11,538 nouns related to 190 unique roles in a dataset of 126,000 images. As you can see from the images below, the same verb, clipping, can be used to describe different actions, such as a man shearing the wool of a sheep, or a vet clipping the dog's toenails. Similarly, the verb spraying in the third picture from the left can be used to show a man painting a wall using a spray can, or a fireman putting out a fire by spraying water. The implications of situation recognition are vast, extending to fields like image and video understanding, news extraction, and image retrieval. Now let's delve into some of the notable works that have shaped our understanding and approach. So the previous state-of-the-art in situation recognition was CoFormer, or a collaborative transformer, which is a two-stage framework that utilizes two transformers. In this paper, the glance transformer predicts the main activity to figure out what is happening, and the gaze transformer analyzes the entities engaged in the main activity and their relations. Clip event is another paper that leverages Clip for connecting text and images with event structures, addressing some challenges in semantic role labeling. However, a key difference from our work is that in this paper, Clip is fine-tuned to gain event structural knowledge. This project also uses negative prompts to create challenging negative descriptions, and designs an event graph alignment loss using optical transport for capturing the event argument structures. So our motivation for this project is as follows. Image region classification are not usually trained to detect context-dependent semantic roles, and visual language models such as CLIP jointly capture image-text similarity in different scenarios. Through our experiments, we also realized that fine-tuning CLIP and using GPT-3 to predict a prompt, such as the agent is a role of that verb, is shown to be not as effective. NLP on top of a visual language model using fine-tuning CLIP for classification is not applicable for conditional predictions of roles. Therefore, we need a conditional prediction network for semantic role prediction that leverages on CLIP embeddings. Now let's dive into our approach. We created 3 different neural networks for our paper. The ClipSitu NLP, which is proposes a modern multi-layer perceptron block that learns from multimodal information of images, verbs, and role CLIP embeddings for semantic role labeling. Image embeddings provide context about the possible nouns for the role, while verb embeddings provide the context on how to interpret the image situation. As you can see on the leftmost side of the diagram, that is our ClipSitu NLP architecture. This takes in the image, verb, and role embeddings and passes it through some NLP blocks, and then using cross-entropy laws classifies the predicted noun. We extend the NLP by exploiting the interconnected semantic roles and verbs and predict them in parallel. So the ClipSitu transformer, which is on the architecture, which is on the right side of the image, it shows that the image, verb, role, and all the consecutive roles for that verb are all fed at the same time simultaneously, and the transformer model predicts the nouns simultaneously as well for each role. Finally, using our learnings from ClipSitu MLP and Transformer, we developed the ClipSitu cross-attention transformer. Each semantic role is played by an object located in a specific region of the image. So we model how each patch of the image is related to every role of the verb. ClipSitu XTF uses cross-attention between the semantic role queries on clip-based image patch embeddings of the image to predict the noun. Cross-attention scores connecting each image patch embedding to each role is used to localize these nouns. So let's get an idea of the performance of our model on current state of the art. For grounded situation recognition, ClipSitu XTF shows massive gains, about a 14.1% increase for value, which means one role matches the ground truth, and 9.6% increase for value all, which is when all the roles match the ground truth. We also get a 12.6% improvement in verb prediction and 20% improvement for grounding value. So this tells us that ClipSitu can align language and visual modalities for situation recognition without even fine-tuning CLIP, such as CLIP event. We also compare the different image encoders from CLIP as well as the complexities of our models. So on the left side in the graph, we test out 4 different CLIP image encoders, which is the Vision Transformer B32, B16, L14, and the largest L14 at 336px. As you can see, this tells us that even simple but cleverly designed NLP modules are comparable in performance to transformers once you leverage CLIP embeddings. ClipSitu XTF also improves upon CoFormer in terms of inference time and parameters. And so as you can see, the ClipSitu XTF has 45.3 million parameters, while CoFormer has about double of that, and ClipSitu has only uses 110 gigaflops, while CoFormer has almost 10 times of that. Furthermore, ClipSitu XTF also has 1/3 of the inference time of CoFormer. Now let's take a look at some qualitative results where ClipSitu excels in predicting complex situations, highlighting its advanced understanding compared to other models. So we're comparing ClipSitu XTF and CoFormer here, and this shows you that the abstract verbs such as cramming in the second image from the left, CoFormer predicts eating, while ours manages to predict cramming. Even though both words are very similar in meaning, the context determines our model. The context helps our model to better understand what to predict. Another example is the second image on the right, which shows a man bowing down. The ground truth verb is begging, which our model is able to predict correctly, while CoFormer focuses on the bowing as opposed to the main action begging, which is visible by the hat on the floor. So in conclusion, ClipSitu represents a significant advancement in semantic role labeling and situation recognition, especially for conditional prediction tasks, demonstrating the power of our approach over traditional fine-tuning methods. Thank you. Feel free to access our project repository, which is the QR link on this slide.